it's almost the whole page. All right, so we're gonna memorize all trans retinol, OL. We're gonna memorize not the numbers or anything, just so you can see. All trans retinoic acid, which is exactly the same as all trans retinol, but with a carboxylic acid group at the end. We're going to memorize 11-cis retinol, AL, and only because we need that later in the I. And then we're going to memorize all trans beta carotene, which is down at the bottom. So there are 4 of them, but most of them are pretty distinct from each other. If you find, so in retinol, it ends in an OH, which is what the OL ending means as an alcohol. And you notice there are 1, 2, 3, 4 trans bonds attached to this 6 carbon ring. Retinoic acid is exactly that structure with a carboxylic acid group at the end. Same exact structure, no changes. 11-cis retinol, AL, has a cis bond in it, right? Instead you've got 2 trans and 2 cis. And then it's an AL, so we've got the double bonded O at the end. And then all trans beta carotene. Beta carotene is essentially 2 retinols stuck together, which is why we can break it down and use it, but why it's treated differently in our body. Because I'm sure this came up in 317 or another class that beta carotene is the non-toxic form and retinol
is the toxic.
or retinal is the toxic form. So if you look at the way these things are configured, that might give you some clue as to
So that's what I wanted to ask. All those trans bonds there, isn't that the reason that it could be toxic to the blood?
So, okay, so yeah, the trans bonds can cause a problem, but it's also because of the way we build it up and store it. In other words, so this is, they can't react, right? If they're trapped in both ends by the circles, this beta carotene is non-reactive. In order to get it to be a reactive compound, we have to break it into 2 retinols or retinals. So yes, the end result is yes, the active part of this molecule is protected by being stuck together. But in the intermediate form, it's not toxic to us because we store it in an unreactive form. Does that make sense?
Mm-hmm.
Okay.
So
If it's the same.
if it's an OH, right?
Mhm.
If it's an alcohol form, it's also toxic to the liver as an alcohol would be because we would it would turn to ethanol eventually, or
So it would be really hard to turn this molecule to ethanol. Part of the problem with, say, retinol versus retinal has to do with the reactivity at the end, right? When you take this proton will pop off pretty easily, and then you've got the negative, and then that can go around and do damage. We actually, when we store this, we esterify it. And so, because we break it when we need it, and we're going to look at where we use it in the eye, because it's a good example of how we turn it into these different forms.
Mhm.
But yeah, so it's more about this particular end part becoming a problem than that we actually turn it into a typical alcohol, like an ETOH or something like that. Okay, so one more time to recap. All trans retinol, all trans retinoic acid, 11-cis retinal, and all trans beta carotene. So those 4, and I'll type those up right now.